Welcome to my presentation. I'm Zainab and I'm going to present you about the rise of modern science and technology 1895 to 1945. Einstein's theory is called the special theory of relativity because it applies the principle of relativity only to systems in uniform motion related to each other. Because of the principle of relativity, passengers who are traveling smoothly in a train cannot tell whether they are moving or not unless they look out of a window. The station becomes different if the train is uniformly accelerated. The passengers will feel a slight push in the direction opposite to that in which the train is moving. This term is acceleration force. Because of this extra force, it appears that the laws of physics would be different for bodies accelerated with respect to each other. The age of Earth. Mikhail Lomonosov in the 18th century was among the first to see things differently. He thought from geological evidence that Earth must be hundreds of thousands of years old. Radioactivity also provided the solution to finding out how old rocks really are. The current best estimate for the age of Earth based on evidence from meteorites is 4 billion 600 million years. The size of the universe. The strongest confirmation of the Big Bang theory was the discovery in 1965 of cosmic background radiation by two physicists from Bell Telephone, Arno Hippazias and Robert V. Wilson. While experimenting with a very sensitive microwave antenna, they discovered the hits at a wavelength of 735 centimeters, with an intensity that seemed independent of the orientation of the antenna. Such radiation had been predicted by Gamow. The his corresponds to radiation emitted by a body at a temperature of 3 K, the temperature of which the universe is believed to have cooled as a result of its expansion since the Big Bang. The quantum. Although Schrödinger's wave equation gives good results, they are not perfect. The wave equation does not take spin or the theory of relativity into effect. In 1928, Paul Dirac revised the equation to include spin and relativity. Dirac's theory was important because it revealed for the first time the existence of antimatter, but the mathematics is so complicated that physics still uses the Schrödinger wave equation. Dirac's theory essentially completed classical quantum theory. After World War II, physicists developed quantum electrodynamics, a method of calculating the behavior of electrons and other particles that is even more precise than classical quantum theory. Early digital computers. Except for a few analog computers used in special applications, all electronic computers today are digital. Digital computers were first experimented with during the late 13th and early 14th. They use binary numbers to represent numbers and characters and to perform calculations. Binary numbers consist of O's and ones and are therefore best suited to be handled by electronic circuits. The Manhattan Project. After the war, the facilities continued at the first to design and make nuclear weapons, but gradually lost, almost become a national physics laboratory with many projects. Oak Ridge is also a national laboratory, but continues in the business of but continues in the business of enriching uranium for peaceful nuclear power projects while Howard was dismantled, except for a museum about the Manhattan Project, becoming a major environmental problem of the 21st century. The first working computers. Defense needs in World War II were the driving force behind the development of the first large electronic computer built in the United States. Scientists and defense. The outcome of World War II was determined to a large extent by certain technologies developed by the Allied forces, especially the United Kingdom and United States. This concludes my presentation. I hope I have been clear. Thanks for listening.